Hello calculus learners, welcome back to my channel. So in this video we're going to do practice about algebraic limits. Okay, in this video we're going to solve 8 problems involving the algebraic methods that we need to apply whenever we try to plug in at a discontinuity. Okay, alright, in the first problem we have limit x approaches 0, 5x cubed plus 8x squared over 3 times x to the fourth minus 16x squared. So in this case, when you substitute 0, you're going to end up with definitely 0 over 0. Okay, which means we need to apply factoring method, because the factoring method is the most suitable method to this kind of limit. All right. So, but we need to determine what is the common factor. So what is the common factor that I need to pull out of it? Okay, so we get limit x approaches 0. So for these two pieces on top, the very common thing is, x squared. So when you factor out of x squared, you get what's left in the first piece will be just 5x, and what's left right here will be just 8 over. And when you look at these two pieces on the denominator, the common thing is x squared. So when you factor out of x squared, you get 3x squared minus 16. And notice that we have these common factors, x squared on top, x squared on the bottom, so they're going to be gone. And then it's pretty safe to apply plug-in. So when you plug in 0 into this expression, you get 5 times 0 plus 8 over 3 times 0 squared minus 16. And then 5 times 0 is 0, and then we get 8 on top. And 3 times 0 squared is 0, and then we get negative 16 at the bottom. And this expression will be reducing to a negative 1/2. So that's the first answer. All right, let's move on to the second problem. In the second problem, let's try to plug in 2 and let's see what's going to happen. So we get 2 cubed plus 2 times 2 squared minus 13 times 2 plus 10 over 2 cubed plus 4 times 2 squared minus 4 times 2 minus 18. And when you evaluate top and bottom, you're going to end up with this 0 over 0. Okay, so in this case, we need to apply synthetic division. Okay, so you need to divide this top expression by the bottom synthetically. Okay, so when you do that, I'm not going to go into that detail. I'm not going to do the synthetic division. But when you do that, you're going to end up with this expression, limit t approaches 2, t minus 2 parentheses times t squared plus 4t minus 5, and over t minus 2 times t squared plus 6t plus 8. And notice that when you apply the synthetic division, it produced these two common factors, so we can divide them out. So when I do that, and after that, we can apply plug-in. So let's apply the plug-in. So we get 2 squared plus 4 times 2 minus 5 over 2 squared plus 6 times 2 plus 8. So this is 4, this is 8, 4 plus 8, 12, 12 minus 7, 12 minus 5 is 7 over. And this is 4, and this is 12, and this is 8. So when you add them up, you get 4 plus 12, 16 plus 8, we get 24. That is the limit value. Okay, so for this second problem, we applied the synthetic division, so we can produce this common factor, so we can divide them out, and then we applied plug-in method. Okay. And for the third problem, as you can see, we have complex fraction. So whenever we have complex fraction, we need to apply the, we need to deal with this top expression. Okay. So the way we can deal with this top expression is, I'm going to give you the shortcut way. I'm going to show you also limit x approaches 5. So we're going to multiply this 2 by 4. Okay. Basically, we're going to do cross multiplication. So when I do cross multiplication, we get 2 times 4 is 8. Okay, and minus 1 times x plus 3. and over 4 times x plus 3, and this x minus 5 is coming from the denominator. Okay, so limit x approaches 5. So 8 minus, if you distribute this -1 into the parentheses, you get 8 minus 1 minus 1x and minus 3 over 4 times x plus 3 times x minus 5. Right, so let me erase this part. Okay, so we get limit x approaches 5. So x minus 3 is 5, so we get 5 minus x over 4 times x plus 3 times x minus 5. At first, you can say that these two are not factorable, they can't cancel each other out. But when you multiply this 5 minus x by -1, you're going to end up with this expression in the denominator. So basically, when we try to simplify them, we get -1 on top, and we're going to apply the plugin. So we get -1 over 4 times 5 plus 3 times 4 times, yeah, 5 plus 3, that's it. So -1 over 4 times 8, and then we get -1 over 32 as the answer of the third problem. Okay. All right, for the next problem, let's move on to the next problem, but I would like to erase the board really quick. Okay. Okay. In the next problem, let me use different, more vivid color, let's say. Let's use black one. So, in the fourth one, we have limit x approaches 0, 2 plus x all cubed minus 8 minus x divided by x. So I can rewrite this limit as limit x approaches 0, 2 plus x all cubed minus 2 cubed over x. And notice that this is difference of cubes, okay? Difference of cubes with minus sign in between them. So what do we do if we have x cubed minus, I'm going to rewrite it over here. So if we have x cubed minus y cubed, the way we try to factor this expression is x minus y times x squared plus xy plus y squared. So we're going to exactly apply the same thing into this top function, and let's see how it's going to turn out to be. Okay, so limit x approaches 0, 2 plus x minus 2, because there's minus sign, times, parentheses, 2 plus x squared plus 2 plus x times 2, and plus 2 squared, and over just x. I'm going to continue from up here, okay. Limit x approaches 0. So 2 minus 2 is 0. And then what we have left is only x. X times, we got this one, 2 plus x squared plus 2 times 2 plus x and plus 4, which is a polynomial expression which we can apply the plug-in method so quickly and easily. And these two x's are going to be gone, okay. So we get, if you apply 0 right here, if you plug in 0 right here, if you apply the plug-in, so we get 2 plus 0 squared plus 2 times 2 plus 0 and plus 4. And now we get, this is 4, and this is 4, and this is 4, so we get the answer as 12. Okay, for the fourth problem, we just apply the cubes, difference of cubes from the pre-calculus and algebra 2 skills. We just use them. Okay, all right, let's move on to the next problem. All right, here we go. In the next problem, we have radical expression. So whenever we have a radical expression, we need to multiply top and bottom by the conjugate of top expression. So when I say conjugate, which means a plus b If I'm being asked to find the conjugate of a plus b, that's going to be equal. That's going to be equal to just a minus b. Okay. If I have square root of x plus 1, and if I'm being asked to figure out the conjugate of this expression, that's going to be equal to just square root of x minus 1. Okay. So in this case, the conjugate of this top expression is square root of x plus 6 plus 3, which means I'm going to multiply top and bottom by that conjugate. So let's do that. Limit x approaches 3, square root of x plus 6 minus 3 times square root of x plus 6 plus 3. You see that I multiplied it by conjugate, and over x minus 3 times square root of x plus 6 plus 3. Okay. So I just want you to focus on this product. So basically that product is actually expansion of difference of squares, which means limit x approaches 3, square root of x plus 6 all squared minus 3 squared over x minus 3 times square root of x plus 6 plus 3 equals limit x approaches 3. The first one will be just x plus 6, and the second one will be 3 squared, which is 9, and over x minus 3 times x plus 6 under the square root plus 3. And if you focus on this top expression, x plus 6 minus 9, it's going to be equal to just x minus 3. And we can simplify these two, okay? And then we get limit x approaches 3, 1 over square root of x plus 6 and plus 3. So now we can apply the plug-in method. So we get 1 over 3 plus 6 under the square root plus 3. And 3 plus 6 is 9, square root of 9 is 3. So we get 1 over 3 plus 3, which is just equal to 1 over 6. Okay. And for the next problem, again, it's involving, radical expression. So whenever we have radical expression, we need to apply rationalization. So let me quickly erase that. Okay. So if we need to find the conjugate of square root of x minus 1, which is equal to square root of x plus 1. So I need to multiply top and bottom by this conjugate. Okay. So let's do it. Limit x approaches 1, 2x minus 3 times square root of x plus 1 times square root of x minus 1 over 2x squared plus x minus 3 times square root of x plus 1. Okay. So from there we get limit x approaches 1, 2x minus 3 times just x minus 1 on top and over. So now we need to factor this expression. And that'll be just 2x and x, and this one will be 3, this one will be negative 1. So we get 2x plus 3 times x minus 1 times square root of x plus 1. And notice that we got these x minus 1s as common factor on top and on the bottom, so we can simplify. So we got limit x approaches 1, 2x minus 3 on top, and then 2x plus 3 at the bottom times square root of x plus 1. So now we can apply the direct substitution. So let's do that. We get 2 times 1 minus 3 over 2 times 1 plus 3 times square root of 1 plus 1. And the top will be just negative 1 over bottom will be 5 times 2, and then we get just negative 1 over 10 as the value of this limit as x approaches 1. Okay. All right, the next problem, we have a limit involving trigonometric function, but before that we need to divide this entire expression by x. Basically, I need to divide each of these pieces on the top by x. So let's do that. Limit x approaches 0, 4x over x, and plus sine of 2x over x. And remember that from the properties of limit, I can rewrite these two expressions as separate limits. So we get limit x approaches 0, 4 plus limit x approaches 0, sine 2x over x. Okay. The very first one is very simple, because when you take the limit of a constant number at any point, it's going to be itself, which is the constant number. And now we're going to focus on this trigonometric limit. That's going to be equal to 4 plus limit x approaches 0, sine 2x over x. And notice that this inside function is 2x. So basically I must have 2x at the denominator. So then I'm going to follow up this method. 4 plus limit x approaches 0, sine 2x. So basically I'm going to multiply top and bottom by the same number. And I'm going to multiply and divide by the same number. So which is 2 and over 2x. Okay. And we get 4 plus limit x approaches 0, 2 times sine of 2x over 2x. And notice that this is the form that we want. Okay. You can also put this 2 out front, so you get 4 plus 2 times limit x approaches 0, sine 2x over 2x. And this expression is equal to just 1. And then we get 4 plus 2, which is equal to 6. That's the value of this limit. Okay. So basically, calculus is mostly built upon, algebra 1, algebra 2, and pre-calculus skills. So we're going to be using algebra 2, algebra 1, geometry, and pre-calculus a lot. Okay, so those skills are going to help us a lot too much. Okay. All right, let's move on to the next problem. Before that, I'm going to erase it. In the next problem, again, we're going to apply factoring skills, okay, before we evaluate the limit involving trigonometric function. So the way we evaluate this limit, first of all, I'm going to apply factoring. So limit x approaches 0, sine x over. So for the bottom function, we have x as the common factor. So if I factor out of x, and we get 5x minus 1, okay, then if I manipulate this entire expression into this expression, so basically I'm just going to change the location of the things. So limit x approaches 0, sine x over x times 1 over 5x minus 1. Okay, remember that limit of the product of two functions is going to be equal to the product of two separate limits. Then we get limit x approaches 0, sine x over x times limit x approaches 0, 1 over 5x minus 1. And we know the first limit is a famous trigonometric limit, and that's going to be equal to just 1, times, for the second limit, you're going to substitute 0 into this function. It's not going to cause any kind of indeterminate form. So we get 1 over 5 times 0 minus 1, and then we get 1 times negative 1, and the limit is going to be equal to just negative 1. All right, guys. In this video, we've solved 8 problems detailed step by step. And these questions are ranging from the questions involving complex fractions like this, and also questions involving difference of cubes, and also questions about this radical expressions, and also trigonometric limits. All right, so I've tried to explain things step by step and in detail. And thank you so much in advance for watching this video. See you in the next practice video. Bye-bye.